Hello friends, welcome to our channel Mirror Neuron, which means watch and learn. And today we are going to continue with the part 3 of our recommendation system using machine learning and Python. Alright, so in part 1 and part 2 I'll quickly summarize what we have covered. So we first of all saw that if we have some data and along with it we also have the order number, we basically intend to find out the item pairs and how many times those items has appeared in the first place. And then on top of it, are we able to derive some information such as support, confidence and lift. So if you want a refresher, maybe you can quickly go to part 1 and part 2 and then come on to this part 3 today, where we are going to look into the actual data set and see how it looks like, and then we can decide what changes do we have to make into the data set so that we can make it ready for our actual usage, where we are going to apply the a priori algorithm and the association mining rules, right? Okay, so from this point onwards, we will be using a couple of libraries such as pandas, numpy, the inbuilt sys library, the iter tools, because it will help us use the combinations and group by, which we saw in our example in part 1 and part 2. Then we have the collections for counting the pairs, and then we are going to use the ipython.display function so that we can show multiple print statement within the same Jupyter notebook. Okay, so as I was telling you at the very beginning of the project in the part 1, that we have a large data set for our machines to process in this particular case. So we have over 1 GB of data, and typically our computers are already filled with so many other programs that we barely get any hardware to do machine learning with huge data set, right? And it creates a lot of problem for us. So in this case, we will see how we can use some kind of generator tools within Python so that we can read the data as and when only required, right? We are not going to read the entire data set at all point of time. Rather, we'll read it as and when we require it. That's the beauty of these generator functions. For example, this iter tools actually provides us with those. Okay, now in order to start, we will first begin with seeing how much the data set size is. So for that, we can use the system function get size of an object, and we are dividing it by 1000 by 1000 so that I can convert that into a megabyte, right? That's a simple function. So it will take an object and it will just divide it by 10 to the power 6 to give us the size of that object in megabytes. And basically we are interested to know how much space it is going to take in our machine. So just to give you a heads up, I'm using purposefully a 8 GB laptop to process this data. Okay, so if you have a minimum 8 GB laptop, you should be able to run this project along with me. Okay, and then I'm also using the import time library to see how long does it take to read this 1 GB of data in my machine. So it will slightly vary in your machine as well. If you have higher RAM and stuff, it might take even quicker. Okay, so all I'm doing is reading the CSV file order products prior, and as I told you, you can download this data set from the Kaggle site, which I have shared in the description section as well, and you can practice it along with me. Okay, so I can use my the size function here, and I can also print out the time it has taken to run both the code. So what it says here is that the dimensions that I have is it has around 32.4 million records, and you can see the size is well over 1 GB, so it is about 1.04 GB of data. And you can see in my machine it took me roughly around 21 seconds to read the data and print this statement out. Okay, so from that I can say that yes, I have a large data set, and I'm not going to read the entire data set at one point of time. I'm going to while I'm processing them, I'll process chunk by chunk. Okay, all right. So now if I quickly print the data, I can see that the data contains an order ID, it contains a product ID, and it contains another field called add to cart order, and then the reordered, whether that item was ordered again or not. So whenever we design a machine learning solution, we should be preparing a flowchart, and I keep telling this in all my projects, that you should know what you are going to do next, right? Because that will help you keep a track that where exactly things might fail, and you can come back and fix that portion instead of just wondering what's going on. So typically while you do the exploratory data analysis, you'll be able to come up with these steps, and you have to be very particular that how your data looks like. Is it ready to be fed into the machine learning algorithm or not, or do we need to process it some way or the other? Here we are going to explore a few of those techniques, and so that we can use this data, format it in a requirement so that we can apply this into our a priori algorithm or my association mining rule. Okay, keep that in mind. Okay, so one difference we can see with the example that I was using, where we had apple, egg, broccoli, pickle, and some exotic fish, and some other examples like apple and egg. You can see that we were dealing with product, the order ID, right, and then it has order item name. Okay, in our case, if you see here, it's product ID. I'm not using the product name at this point of time because I find it more comfortable to work with the numbers. Later on I can just do a quick join or merge to get the product name, but right now I'm not interested because I'm not doing anything with the product name at this point of time. Eventually I will see that even product name gives us a lot of information. So for example, why product name could be important? Because product name probably have different flavor of ice cream, and the product name says some of them ice creams are of strawberry flavored, or some are kiwi flavored, or some other flavored. So the name itself will give you some idea to recommend the products, right? Not the product ID itself will not be sufficient. Okay, now I've just pasted my example data here just for your comparison. Okay, so you can see we have to understand one thing, that we have to have our order ID in a sequence, and the items those were purchased in that particular order. So you have to make sure that your order ID are in sequence, because we also saw in our part 2 of the video that if the order ID is not in a sequence, then the algorithm will not be able to find that out. So it will create some issues, and it will not take some orders in account. Okay, so you can watch the part 2 if you want to identify what those problems could be. Okay, so what I'm doing is I'm quickly setting the index, right, and I'm taking order ID as my index, and I'm also along with it taking the product ID. I could have renamed this product ID to item ID just to be consistent with our example, but that is totally up to you. So now I have basically a series, right? I can convert this into a series. Earlier I had a data frame where we had 4 columns. Right now all I need is a series with an index. So I'm setting the index to be as order ID, and my product ID as my values of that series, right, at each of those indexes. So now you can see my data set, which is basically a series now. If I for the timing ignore the other 2 columns, add to cart order and reordered, you can see that it looks more or less similar to the one that I have just above on the top, where it says order ID 1 apple, order ID 1 egg, and so on, right? Looks very similar because that's the format I want, so that I can apply my logical processing for doing the a priori algorithm. Okay, so now that we have the data set in place, now that it's converted into a series, let's do few basic checks. So I can use my basic shape and index.unique method and the value counts, the standard functions from my pandas library. I can quickly see that there are over 32 million orders. It has 3.2 million unique orders. So just for your information, you can see they have roughly 10 items per order. Okay, so that is why it becomes 32 point something million orders. Okay, just to give you a heads up. Okay, and there are roughly around 50,000 unique products. So it's a big data set. So this way we can get a quick glimpse of the data that we have. Now in order to process this, as we have seen in our example, toy examples, we saw that we have to create some functions to calculate this support, the confidence, and the lift, and we will see how we can do that in our next video, where we'll be actually doing step by step understanding first that why do we need those helping functions, so that it can help us quickly create those other calculations. All right, so if you need some refresher about the what we covered in part 1 and part 2, please visit just try to cover those sections. It will give you a clear idea why we are taking this particular approach, and it will also explain the steps that we are going to do in future. Okay, so that includes, we want to set the support value, the lift value, the confidence value, and so on. And also we want to count if certain items has not been ordered too much, we'll try to ignore those so that it does not mess up with our calculuses and unnecessary analysis. All right, so now that you have know what we are going to do next, I will request you to please subscribe to our channel to stay updated, and whatever you feel like about our projects, please do comment so that we can improve next time. All right, thanks for watching and you have a great day.